Here we go. So I said every line in every application question actually tells you something. So we read the first line. It says find two positive numbers, the sum of which is 8. That right there, I would stop there and say, what is that trying to say? Well, that step right there, what do I want? The sum of two positive numbers is 8. So if I were to write that, I would say, let's say the first number was x, and let's say the second number was y, and sum means add. So x plus y, it says, which is 8. So that means it's equal to 8. That's my first equation. That's what I would do first. Then the next part, it says, and such that the sum, so again, another add, or another addition, of the cube of the first and the square of the second. Okay, so if I write that expression down, they said this cube of the first, so if the first was x, then I cube it. Sum means add with the second that is squared. It says square of the second, so second one is squared. And the problem is it didn't tell me what it equals to. It says to equal a minimum. Now hopefully what you picked up in differentiation, we can always find maximum and minimum. Maximum minimums, remember the maximum or the minimum. We know that at the maximum or the minimum, what's one thing that you know? What's one key thing you know at the maximum minimum trend?
The gradient equals 0.
Yeah, the derivative of whatever the equation is, at this point the gradient is 0. So your goal right now is to get an equation. Okay, but the problem is this doesn't look like an equation at the moment. Okay, you're going to try to get an equation, and the only way to get a minimum is if you found the derivative to equal to 0. That's your goal. See, once you can write an equation, that's the hardest part. Get the equation from the two pieces of information you have. The next step is derivative equals 0. So that's easy. That one you can do in your CAS and get your answer. But the hardest part right now is to form your equation. Okay, so how do we do this? Well, if you think about it, it says the sum of, this is our first equation. It just tells us that x plus y equals to 8. Okay? And such that the sum of the cube of the first and the square of the second is as small as possible. Now, I've got x plus y equals 8. I can rearrange that if I wanted to. Okay? I can rearrange that and you could get y equals to 8 minus x. Okay? I'm just thinking there needs to be one extra small thing. They haven't told sum of the cube of the first and the square of the second. I just realized that sounds a bit funny. Let me just do that again. Sum of two positive numbers, which is 8. X plus y is 8, such that the sum of the cube of the first and the square of the second, which I've done right, is as small as possible. Yeah. The reason why I'm a bit iffy about this, and I'll tell you why, I feel that the reason why x, if you replace the y right now in the second equation, you have x cubed plus y squared. You can replace the y with 8 minus x, and then you have x cubed, but it still doesn't equal to anything at the moment. So we'll call it an expression then. Whatever that equals to, we'll call it, let's call it m. Sorry? 8 minus x.
Yeah, 8 minus x squared.
Oh, yes, you're right. Thank you.
Find the derivative of both of those, so that equals 0.
You could. I think,
Plus.
yeah, I'm thinking whatever this equals to, we are trying to find the derivative of this equation. We say that whatever m is, that's the answer, but we want it to be the minimum. So dm dx, which we can find the derivative now, we've got x cubed plus 8 minus x all squared. Sorry, I should call that m. And your goal is to find the derivative of this equation. So here we go. We've got m equals to x cubed plus 8 minus x all squared. This is my equation. I don't know what m is because they've never told me what the answer is. But I know that x cubed plus 8 minus x all squared needs to be a minimum. Now the only way to get the minimum there is if I find the derivative. Now you don't have to do it by hand, remember, it's an application. So if you can define this on your calculator, and you can call that y if you wanted to, but we use the y over here. So I'm going to call that m. And we're going to find the derivative of x cubed plus 8 minus x all squared, and then we'll try to solve it. So here we go. Let's use the CAS. Now we've got an expression. We have, let me just move this around. Here we go. This is our expression. On your CAS, move to your CAS. Here we go. Let's start new. We want to define, every time you do these, I want you to define the function first. Okay, so here we go. Menu, actions 1, 1, define. I'm going to call the function, okay, so it should have been m, but I'm calling f now. So f of x is equal to x cubed plus 8 minus x all squared. Okay? That tells me the function. What did I want to do to the function? I want to derive it. I want to find the derivative when it equals to 0. So here we go. How do you derive? Here's the shortcut. I'll show you the long way and then I'll show you the short way. Menu calculus, which is what we're under, for derivative, which is 1. That finds you the derivative. Now, instead of doing menu for 1, what you can do is you can do shift minus. So one way to remember it is because, you know, with the power rule, you minus the power by 1, then it's minus. Antiderivative, you add the power, then it'll be shift plus. Okay, so shift minus gives you the derivative. Now, what are you... This is what you're deriving. What you're deriving, and in here is what in respect to. Now, it's respect to x, because we're deriving in terms of x. So here we go, we've got x on the bottom, move to the next side, and we say find the derivative of f of x. If I press enter, this is my derivative. Okay, that's my derivative. Now, what do we want? Again, we want the derivative to equal to 0, because that's what we said. We said maximum and minimum occurs when you have the derivative equals to 0. So I found the derivative now. My tip for you at this point is to also define, because when you're doing applications, likely you're going to use the derivative more often later. I would suggest to you to define this one too. So what I would do here is I'll go back and go menu 1, 1, so define, and I'll call this g of x now. So g of x will represent the derivative. Okay, so you can call it whichever you want. I'm just going to move the cursor up to 3x squared. So define g of x equals to, highlight the derivative, and I press enter. Why did I do that? Because now f of x will represent the original function. G of x will represent the derivative. Okay? And what did I want to do again? I said I wanted to solve the derivative to equal to 0. Technically on the calculator, not on the calculator, by hand, what I want you to do is now solve for that. 3x squared plus 2x minus 16 equals to 0. I want you to solve for x. Now instead of doing it by hand, we can do it on a CAS. So how do we do it on a CAS? Literally type in the solve. Remember, at the start of the year I taught you define, solve. Yeah, define and solve in Sketch. So how do you solve? Menu, algebra 3. So menu 3, 3. Whoops. Menu 3, 1, sorry. Menu 3, 1 is solve. What am I solving for? I want the derivative, which is g of x. What did I want the derivative to be? At the maximum minimum, the derivative, which is the gradient, should be 0. So this should equal to 0. But what am I solving for? So I put a comma. The derivative equals 0, comma. What I want to solve for? I'm trying to solve for x. X was one of the positive numbers, right? So if I put x in, press enter. Now I've got two numbers here. I have x equals negative 8 on 3, or x equals 2. Which one of those is the correct answer? 2. Why is that? Because it said two positive numbers. It can't be negative 8 on 3. So if I go back here, what I just did was I said dm dx. So I found the derivative, and we had dm dx as 3x squared plus 2x minus 16. Then I said solve for it to equal to 0, 3x squared plus 2x minus 16. And I got my answer as negative 8 on 3 and x is equal to 2. But because they said two positive numbers, and x is one of the numbers, x has to be a positive number. So x plus y, x has to be 2. Now if, therefore x equals 2, since x has to be positive, which we say greater than 0, therefore y has to equal to what? Now let's think about it. If this is 2, 2 plus what will have to give you 8? 2 plus what? 6. So y has to be 6. Okay, and that's a positive number as well. So I know that when y equals 6, x equals 2, that will be a minimum. How do I know it was a minimum? Because I did that before. I said find the derivative of this. When that equals 0, I should have the minimum or a maximum. And it was one of these two. One of them is a maximum or a minimum. But because it's the positive value, it had to be this one. So therefore, this must be the minimum. You can probably prove it's a maximum minimum by sketching it. But I've just used my CAS to answer the questions. Okay. So what was the hardest part? This is the hardest part. This is where I kind of tripped up just now, where I said I wasn't sure what it equals to, and you didn't need to know. It was just an expression. So I made up the letter m. Once I had the equation, it was easy. Find the derivative equals 0 allows you to find the stationary points, maximum or minimum. Okay? How do we feel with that question? We're going to use the same techniques I just showed you for question 1, and we're going to do the same thing over and over. For each of those questions, the hardest step is getting back, getting the equation. You get the equation, everything else is easy. Okay? So we're going to do the same steps. Define, solve, derivative. Define, solve, derivative. Define, solve, derivative. And you'll be using your CAS to define maximum minimums as well. Okay? Now, I'm going to leave just a bit enough so you can still read the notes, but let's read the next question as well. Okay? So here we go. Next question. Remember, the hardest part is to make the equation, and most of these application questions will come with sub-questions. So A, B, C, Ds. Those are designed to help you formulate your problem. It's even easier when you get questions where they say, show that, because that means they give you the equation already. And that's what I did for the SAT, the first one. I gave you the equation. Even if you couldn't figure it out, you can find the derivative. Okay, so here we go. Let's have a look at this question here. It says a piece of wire 200 centimeters long. So I would stop there and say, all right, let's draw the problem. It says I got a piece of wire that is 200 centimeters long. So I'm like, okay, I will draw a piece of wire. This is a piece of wire. And from here to here, it is 200 centimeters long. Great. I've got the length. Then the next thing is bent into a rectangle. So I draw a rectangle. I'm like, all right. I've got a rectangle. But then they said that with length of y and width of x. So this is length of y and width of x. Now the thing that you have to pick up on is, why do they tell you that the length of y is 200 centimeters and then you bend it into a rectangle? What are they trying to tell you there? You have the perimeter. Because you've got a length and you just bent it. So that means the surrounding shape should add up to the perimeter. That was the hardest part. If you could just pick up on that, that's what the application is all about. What you're meant to be able to say is, therefore, P, which is the perimeter, is equal to y plus y and plus x plus x. So y plus y is 2y plus 2x. Now what was the perimeter equal to? We already know the length of the wire, 200. So if I rewrite it, I've now got 200 is equal to 2y plus 2x. And if you read the next part of the question, what do they say? Express y in terms of x. So that was the hardest step. So without me telling you, you were meant to be able to pick up that was the perimeter. Now all you have to do is write y as a subject in terms of x. So I want y equals to something, and it has to have x in it. That's what it means when they say y in terms of x. So all you have to do now is rearrange this so you get y by itself. So if I rearrange it, subtract 2x on both sides, you got 200 minus 2x is equal to 2y. But I don't want 2y. To get rid of the 2, I would divide by 2. So divide both sides by 2. 200 divided by 2 is 100. Negative 2 divided by 2 is negative x. So therefore, this is my answer. So I'm going to say here, divide 2, divide 2, divide 2. Divide every term by 2. Okay, so I've answered the first part of the question. It says express y in terms of x, but you couldn't have done that unless you really read the first line, the perimeter. Okay, next part. And they always do this, by the way. You pick up the pattern with it's either area or volume. They do the same things over and over. So let's look at the next one. It says find the area of the rectangle in terms of x. Don't get intimidated. Just think about it. Area of rectangle. What's the formula again? What's the area? Length times width. Area is equal to length times width. But what is the length and what's the width in this case? The length is y. What's the width? X. So if you rewrite that, here we go. We're going to rewrite that area is equal to length times width, but we know the length is y, and we know width is x. Have I answered the question, though? No, because it says find the area in terms of x. Right now, I don't have the area in terms of x. I got the area in terms of y and x. So what am I going to do with the y? How do I remove that y and just get x's? Yeah, that's the whole point of the first step. Remember I told you all the sub-questions are meant to help you to formulate it. You said here, y is equal to 100 minus x. So replace it. Replace the letter y, because y is apparently equivalent to that. So if I replace it, y is now 100 minus x, and I multiplied by x. There you go, done. That's my expression. That's my area in terms of x. Now what I would do if I was you at this stage is I would define that on my CAS, because the hardest part is getting the equation. Once you get the equation, well, solving for anything else is going to be easy. So I would define it. So I would go back to my calculator now. I would say now, I'm going to clear all this so you can see we're going to start again. Let's clear all this and we say, all right, define menu 1, f of x equals 2. It was 100 minus x multiplied to x. Defined. Okay, now, let's go back to the question. What did they tell me to do? They said sketch the graph of A against X for a suitable domain. What does it mean by suitable domain? What do you have to pay attention to? It has to be positive because we're talking about a length of a wire. You can't have negative length and you can't have negative area. So if you're drawing a graph and it's A against X, well, it makes sense that X is the width. Width can't be negative. And area can't be negative, so your graph can't be in the negative region on this side and neither could it be in this region here. It has to be both positive, so you can only have a graph in this section. So let's test that. Even if you didn't know how to draw quadratics, you've got a CAS. Draw it on your CAS. Let's go back to our CAS. Control Doc. Press Control Doc to add a page. And right here, number 2 is add a graph. Now you defined the graph already. You defined it, so you just have to type f of x and you get your equation. So I type f of x. Now in case you don't know how to get that bar up, press tab and the bar comes up. That's how you type in your function. So you can type tab, f of x, enter. Now, remember I taught you there are a couple of ways to adjust your windows and you have to learn how to adjust your windows. I only taught you 3 things to adjust your windows, okay? It was Windows Fit, Windows Box, and Windows Settings. Don't try to do the zoom in, zoom out. Okay, zoom in, zoom out is terrible. If you really want, what you could also do, if you move your cursor on your calculator, see that middle button there? You can move your button until you get a hand on the x-axis, and this is what you can do. You can move on your x-axis, get your hand, then press onto, hold onto it until the hand looks like it grabs. Okay, so right now it's on an open hand. If you hold onto it, it'll grab. And why would you do that? If you press on it, oh well, you can drag, so hold it and drag, and what it'll do is zooms out on the x-axis. See, I'm adjusting the x-axis right now. I'm just moving the x-axis. I can also do it the same for the y one, but now it's interrupted by the y-axis. You can do that if you wanted to. I wouldn't suggest, like I said, there's only 3 things I've ever taught you. I would say go to Menu, Windows, and there's only 3 things I want you to use. Zoom box, if you have a really big graph and you want a section that you want to focus on. use Zoom Box because you can select what you want. Zoom Fit is my go-to every time. If the graph is too big, I try Zoom Fit just to see if it can fit the graph. Sometimes it does it perfectly, sometimes it doesn't. If it doesn't, that's when I go back to window settings. Okay, so I want you to try Zoom Fit, see if it fits the graph or not. Okay, so I would go to Zoom Fit. I go to Zoom Fit. And there you go. See, this is a much better graph than what I was able to get before. Now you can see it's a quadratic graph. It makes sense, it's a quadratic. I'm just going to move this away so you can see. Now, you know how I said, even though Zoom Fit, it's not perfect because it's so little here, I can't really see the numbers properly. This is where I suggest you to use Zoom Box. Zoom Box allows you to select the area you want. So here we go. We go menu, 4, Zoom Box number 2. I can select the corner. So select one corner, I select this corner, and I select my second corner. I want maybe around here. Isn't that a much better graph? See what I've done? So Zoom Fit, Zoom Box, window settings are your best bet to visualize the graph better. That is a much better graph for you to analyze now. So if you were to draw, you know that you can't have negative area. This wouldn't exist. You can't have negative area here either. That wouldn't exist. You can't also have a box or a rectangle with 0 area. Now this came up in your SACs. I don't think anyone actually did this, but when you sketch, have an open circle when you touch the x-axis. Why? Because you can't have area equals to 0. If you put a dot there, it means you can have an area that's equal to 0. It doesn't make sense. Okay, so it should be an open circle at those ends there. So if you were to sketch this now, going back to our problem, it should be an open, oops, I'll do it in blue, should be an open circle at 0, and then it goes all the way across. That's a bad graph. Let me draw it again. There we go. Now, how do you find the x-axis intercepts? You can either do it on your calculator CAS, solve it, or you can do it on your graph settings as well. Now, here we go. Since we're in the graph, I'm going to show you how to find the x-axis on the graph, okay? So here we go. We go menu, analyze, number 6. Menu 6. Most of the things you need here, maximum, minimums, intersections, they're all here. We normally use the first 4, okay? 0 is your x-axis intercept. That's what 0 is. Okay, so if you want to find your x-axis intercept, 0, here we go. Let's go to this right-hand side. Let's find out. Sorry?
There aren't any. It can't be 0.
Yeah, but you have to label the domain. Remember, it says suitable domain, so you still have to label it, but open circle. So it's up to 100.
Labeling intercepts that don't actually exist.
Yep, with an open circle. So it means it's all the way up to 100. So it could be 99.99999, but it can't be 100. Yeah. Okay. So now I know it's 100, 0, and if you want to find the other x-axis intercept, menu, 6, 1, and same thing again. It should be 0, 0. There you go. Got your coordinates. So I go back. This is how I would label it. I would say 100 and 0, but use an open circle. Keep it as an open circle there. Okay, what are you missing now? You've got your endpoints, you've got your shape. What's another thing you must label? Not the range. Turning point. Every graph is about 3 marks. It's always shape, endpoints, and then turning points. Endpoints sometimes will include your axis intercepts as well. Okay, in our case, our endpoints happen to be the axis intercepts. So our domain is clearly from 0 to 100. Our domain doesn't include 0 and it doesn't include 100. That's my domain there. But you got to find your maximum. Now there are 2 ways to find your maximum. Remember, you can either find the derivative, let it equal to 0 and solve, or easier, use your graph settings and find maximum. Now, there is something I want to make sure that you know when you're doing your maximum. Be careful of this. When you do your maximum, sorry, 6, and you do this, I think it's going to be a nice number. Okay, cool. Okay, good. Now, see this here? A lot of students in their SACs leave it as 2.5e plus 3. Don't write that. Okay, you get 0 for that mark. You actually have to write its full mark. So what's the issue here? Your calculator is currently by default only does 3 digits, 3 significant figures that it sees. So it's obviously larger than 3 digits, and that's why they've summarized it to 2.5e plus 3. You can't write that as an answer. Okay? How do you make sure that you get all full answers? What you should do is you can either move your cursor to the coordinate you want and then press the plus button here. What it does is it expands it a bit. That's the quick way of doing it. Okay, so if I go and press the plus button, I press the plus button, see it moves it out, it expands it. If you didn't want that, what you could do is change the setting. If you didn't want to change it for every coordinate every time, to press the plus button every time, you can go to menu. There are two settings here. Remember, there's document settings, and there's the actual settings for graph. And number 9 there deals with just graphs. So if you go to number 9, see how it's on 3? By default, it's on 3. If you want to make sure it includes all the other digits, because when you're doing applications, it's usually more than 3, go to about 6 or 7. So I'd probably choose 7, and you'll see it'll change the coordinate, or that's as far as it goes, so there's no other digits. But if you had one that had more than 7 digits, that would account for it. Okay? So that's how you change the settings for the graph. And that's a typical one that will come up in your exams when you're doing decimals. Whether it's 1, 2, or 3, make sure to check your graph settings for that one. Menu 9. Okay, so it's in menu 9. Not this one. Don't confuse that settings with document 7 settings. This is for your calculator. Okay, so if you went to menu 7.2, this is your calculator. So that 0.6 radian, all of this is your calculator. When you're calculating stuff, that's what it's doing. Okay? They're two different things. One's a graph setting, one's a calculator setting. Okay? All right, cool. Now, clearly, I've labeled it. I've got 50, 2,500. So we go 50, 2,500. Now, what I want you to understand is, what's the 50 represent and what's the 2,500 represent? You always have to think in terms of application. What is the 50 and what's the 2,500?
It's the width and the area.
Yep. Remember, x represents the width. We said width times your length. Width is when it's 50, you get a maximum area of 2,500. Why do you need to know that? Because let's just leave the next step empty. I did that in your SAC actually. You guys left it like empty. You had the coordinate, you had 1, 1, but you didn't even answer the last question when it was asking what is the maximum area. Clearly the maximum area is at 2,500. That's as far as it goes, and then it drops down to 0. So here, your answer should be 2,500 when they're asking for state the maximal value of the area. Clearly the area has to be 2,500 squared units. I can't remember if it was centimeters squared, is it? Squared centimeters. Okay? And it says and give the value of x. We found the value of x. 50 centimeters. There you go. Okay, so all these application questions are the same thing. Define the function, define the derivative. Okay, now just in case, again, you don't know, if you didn't do it on your graph, you could have found the maximum or the turning point using the CAS section. So here we go. We'll go back to the CAS. If you don't know how to do that, control arrow, left and right. Control arrow will move left and right. Okay, here we go. Find the derivative. I can do it all in one go. I can go define g of x is equal to shift minus the derivative. You can do that all in one go. Okay, and that will say that every time you type g of x, that is the derivative of f of x. What do you want? You want to find the maximum or minimum. That's at a stationary point. Stationary point means that the gradient equals 0. So we go to solve, menu 3, 1. I want to solve for the derivative to equal to 0, find x. That means find the width. In our case, find the width. Now we know the answer should be 50. So the answer here should come up as 50. There you go. Okay, and we did that before. We did on the CAS, now we know x is 50. But how do you find the area then? So we did it on the graph settings, we were able to find 50, 2,500. If you have x equals 50 now, how do you find the area? What do you have to do? Not times 2. Substitute where though? First one. Remember, I called it f of x, but this was your area. It was area length times width. So if you do f of 50, you should expect to get 2,500. So here we go, f of 50. What do you expect if I type g of 50? What should it be?
gradient.
which is?
0.
So if I do g of 50, it should be 0.
Wow. Should
Okay.
we do that whole page?
Yes. That's what I'm trying to say. So, learn to use the define and solve. That's all I've taught you since the start of the year. Define and solve. CAS, Windows settings, through the analyze, maximum, minimum, x-axis intercept, y-axis intercepts. Okay? All right, we've got about 10 minutes left. Let's try the next question now. Let's try. So that was the first part. D, is there an E? No. All right. Here we go. Next section. Same job. I want you to read it. Hardest part is not the calculator. Hardest part is to get the equation. Get the equation and everything should be easy. So read the question. A piece of wire length 800 centimeters. Cut into 2 sections. You've got 2 sections now. One section is to be bent into a square and the other into a rectangle 4 times as long as its width. Okay? Take your time. So remember, each sentence, you need to write something or draw something. So how I would do it, a piece of wire, 800 centimeters. So that's what I would do. I'd do, here we go, 800 centimeters. Okay? That's my length. Now I cut it. I don't know where I'm going to cut it, but I do know I'm going to get 2 shapes. I'm going to get a square. Okay? I'm going to call that X for now. I'm going to get a square, and the next one I'm going to get is a rectangle. I want to get a rectangle. So if I get a rectangle, let's call this, let's call it A. And now, it says that the length is 4 times it is wide. What does that mean? If it is 8 centimeters wide, then that means the length has to be 4A. Okay, so I would have, okay, let's call that 4A now. So that's 4 times A to give you the length. That's my rectangle. So I'm just drawing out what I have at the moment. Now, before you even move to the next step, how do I link 800 square and a rectangle together? Because that's the expression. You can figure that out, then that's the hardest part. The rest is easy. So how do you link 800 to these pictures? Why did they give that to you? Why do you need the 800? What's the point of the 800? Perfect. See, if I added all of this here, the perimeter of all this, plus the perimeter of all of this, it should add up to 800. So write it down. Write down the perimeter should equal to, if I added all the sides of a square, it should have been 4x plus, now if I added these sides, that should be 8a plus 2a. Yeah, because you got 4a plus 4a plus a plus a, but then 8a plus 2a is technically 10a. So you got 4x plus 10a, and we know that the perimeter, as Hamish said, it should add up to 800. Cool, I've got an expression now. That was the hardest part. Get that right, okay? Now, let's read the next part of the question. The question then tells me, find the lengths of both sections of the wire if the total, and this is the key word here, area is to be a minimum. So what are you trying to find to be a minimum? Minimum means that the derivative has to equal to 0, but the derivative of what? The derivative of the area. But how do you find the area?
X times X, 4A times A.
Perfect. The area was of these 2 shapes. Add these 2, that gives the total area. So how do you find the area of this shape? It would have been, so let's write down here, I'm going to write underneath it, area had to equal to the area of a square, which is x squared, x times x. Yeah, plus 4a times a, which is 4a squared. Now, to find the minimum, you have to find the derivative. But the problem right now is you've got 2 variables. You've got x and an a. We need all of this to be the same letter. It's what you were doing in the previous step. They broke it up into steps where you now do it all in one go. Why do we need this? How does this help me to make this all one variable? What do you have to do? Good. You either make x the subject or a the subject. Remember the previous question, you had to find y in terms of x? Well, in this case here, you can either choose which one you want. Now, I'm used to making sure that I have all x's. Because on the calculator, I press x's. So your aim is to find a in terms of x. You can rearrange this equation to get a then you can replace the A here. That's the goal. So here we go. Let's replace the A's. We're going to do 800 minus 4x is equal to 10a, because I subtracted 4x on both sides. I don't want 10a, I want a. I want to know what a is equal to. To get rid of the 10, we would divide both sides by 10. So divide by 10, divide this side by 10. Okay? So technically, this is what I got. I've got 800 minus 4x over 10 equals a. Now notice I didn't even bother simplifying that. Because why? I'm going to use a calculator. I don't care about doing it by hand. You don't have time to do it by hand. Do it on a CAS. So now if I replace it, the area is equal to x squared plus 4 times a. What is a? 800 minus 4x over 10 all squared. See what I've done there? All I did was I took a and I replaced the a over here. Instead of 4a squared, it's 4 that squared. Define this in your calculator. And remember, what do we want to do? We want to find the minimum. How do you find minimum? Derivative equals 0. It's a stationary point. Derivative equals 0. So your goal, we're going to do it again. So here we go. Let's do this on our CAS. Whoops. I'm just going to move this across or zoom it out a bit. There we go. So I'm going to go to the calculator. I'm going to clear history. Here we go. We're going to do the same thing again. Define. What am I defining? My original function. What was my original function? It was x squared plus 4 times, and I had the bracket was 800 minus 4 times x divided by 10, bracket all squared. Okay, that's my function. But remember, that represents area. How do you find the minimum area? It means to find the derivative of that letter equal to 0, because we know the minimum or maximum has a gradient of 0. So here we go. Find the derivative. Again, do it all in one go. I do define g of x equals 2. What's the shortcut for the derivative? Shift minus. So shift minus, I've got x, and I'm now going to say f of x. So what that does now is says every time I do f of x, that's the function, that's the area. When I do g of x, that's the derivative. What do I want? I want to solve when will I have the area equal to 0 or the derivative equal to 0? So here we go. Solve, menu 3-1, so solve g of x, which is the derivative. I want that to equal to 0, and I want you to solve for x, because it's all in terms of x at the moment. All in terms of x, I just want to know, what would the x be? What would the width be? What would this square width be so that I could have a derivative of 0? Press enter. I've got 3,000. Oh, you can't really see it. All right, I'm going to switch it to a wider one. There we go. I've got 3,241. Now, if the question says change it to decimals, change it to decimals. If they don't say it, and at the front it says leave in exact values, leave your answers in exact values. Okay, don't always just switch it to decimals. Read the question. Okay, now a question, I don't remember them saying. No, it doesn't say. Okay, so that's my x value. Okay, but they didn't ask for that. What did they ask? They said, they did. They said find the lengths of both sections of wire if the total area is to be minimum. So I've got the x. What am I missing?
What? No, you guys know why.
I had no y. It's going back here.
You solve for 4x and
So I now know x is equal to 3,241. How do I find a? Somewhere.
4x plus 10.
Yeah. Because remember, how do I find a? It says a equals 2. I found x already. See, I already got x. I just need to replace x here. Yeah? Replace the x, and I'll get a. See what I'm doing there? So really read what you have. This is to find a. This is to find the perimeter, but we really don't care. We know the perimeter is 800. This is to find the area. Okay? Okay, so here we go. We've got this step here. Now we're going to say sub x in. X is equal to 3,241. Type in your calculator. Don't do it by hand. Okay, so type in your calculator. We are now going to go to, what was it, 800, 4 times, do another fraction. Here we go, 3,241. What was it again? 10. There we go, 2041. So that means, therefore, A equals to 2041, but that's just the width.
You gotta find the
And therefore the length,
times
good.
by 10.
This is the width, and therefore length is 4 times A, so 4 times the 2000 is 8,000 on 41.
Wait, what?
Yeah, we
Did you
could.
say find the lengths of both sections? Yeah. Then you have to like times by 10. Times x by times x by 4.
No, because it says the rectangle has 4 times as its width. And we had the width here as A. So the length has to be 4A. We found X.
Oh, when it says the lengths of both sections of y,
Yeah.
does that mean the length?
Well,
Or does that mean the total, like the perimeter?
The perimeter
the wire.
No, the perimeter is 800.
Yeah, but does it mean the length of the perimeter? Because when you say like the length of y,
The length of the perimeter that the wire made, or the length of the wire.
True. No, sorry. You got a point.
You have 2 pieces of wire.
The length of the
You need to find both.
Oh, well, in that case, if it is, yeah,
Isn't it 4x and 10a?
yeah,
Yes.
yeah. So in that case, it will be 4 times this length. So 3,000, 4 times 3,200 on 41.
It was just kind of like
And whatever that equals to. That's 4. All right. 12,800 on 41. And that would be the length for the square. For the length of the rectangle, just do 800 minus that. Because you know they had to add up to 800 centimeters. So if you subtract the length for a square, then you get the leftover length for the rectangle. True? Okay, so
That wouldn't be that.
here we go, 800 minus that, and 20,000. Okay? Now, in terms of what I need to teach you, I've already taught you all the CAS. I'm just getting you to think how to find maximum minimums, yeah? Now tonight, I will be doing exam 2017. It's in the exam resources link. I'll do it from exam 1 all the way to exam 2, multiple choice and exam 2 questions. So you can see how I do that. Okay? And then hopefully I can have it like the If I don't, Saturday, Sunday, you get a video for 15 and 16.
Working some of these things out is a bit
Yes, I'll put a note on all the students who have it. And tomorrow, you will do it
I mean, you don't. It wasn't even me.
Oh, by the way, you can bring your notes for the SAT. The CAT SAT. Yeah. You didn't want to get like
Alright, my pocket feels minty fresh. Because there's 2 packs to come in there.
I'm pretty sure I got it. Like, I think
I only paid on one sack you read her search review. But it was 39.8. So that's what we read like you're like
yes. Wait, let me stop the recording.
I'm not mean to anybody.
Yes.